Hey guys, Mrs. Dan's here. So someone asked me if I could do a video for page 17, but before I do page 17, I just want to show you what your do now should have looked like so that we could talk about some things. So you could have filled in your tables of values using your calculator and then plotted them. And I wrote the functions at the top so I don't have to flip back and forth, and I tried to color code it. And they all look like parabolas because of the x squared, but they're all slightly different. We call this one the parent graph. It's what we compare all quadratic equations to. Its vertex is at 0, 0, and it's got what I call the standard width of a parabola. The width of a parabola can change, and it changes when you multiply it by some number other than 1. So h of x, the width didn't change, but it opens downward because of that negative there. J of x changed width because it was multiplied by 2. It actually became more narrow. Remember, if the number that you multiply by is greater than 1, it becomes more narrow. If it's between 0 and 1, it becomes wider. G of x, it looks like the parent graph, but shifts 1 unit to the right. Remember, numbers inside parentheses are your right-left shifts, and they tend to shift the opposite way of what you would think. And k of x shifted down 1 unit. And you can see that all in a graph. So which function shows a reflection over the x-axis? That would be h of x. The one that looks like it's stretched vertically, they're talking about becoming more narrow. That's j of x. The one that looks like it's shifted left or right, that's g of x, and it shifted 1 unit right. And the function that looks like it shifted up or down is k of x, and it actually shifted 1 unit down. And if you understand these shifts, you can then graph a little more quickly. Maybe it's not quicker, but it's a different way. You don't actually have to use your graphing calculator. Please remember, you're always allowed to use your graphing calculator, though. So if we did example 1, what we can see is that this is a shift 2 units to the right, while this is a shift 4 units down. And that's what they want us to answer for part A. My technology at home isn't as good as what it is at school, so bear with me with the sloppy writing, and hopefully the sound quality is okay. I actually jump right to letter C, because once I know that it shifts 2 units to the right and 4 units down, I know the vertex. 2 units to the right and 4 units down, the vertex is at 2, negative 4, and I actually want to plot that right away. They do ask me to graph it by applying the transformation. So they're talking about plot the vertex, and then since there isn't any number other than 1 being multiplied by this function, the width of the parabola is the same as the width of the parabola you see on the graph. So let's talk about that width of the parabola that they're calling g of x, which really is the parent graph. Take a look at the rates of change. Starting at the vertex, the first point to the right is up 1, right 1. The next one is 1, 2, 3 over 1. The next one is 1, 2, 3, 4, 5 over 1. I'm hoping you're noticing a pattern that the rate of change of the parent graph from the vertex is 1 over 1. Then it's 3 over 1. Then it's 5 over 1. Guess what the next rate of change would be if the graph paper was large enough? Yeah, you're right, 7 over 1. And so on, because this graph really does go on forever in the upward direction. So all parabolas that have a 1 as the number that's being multiplied by. We call that the a value of 1, just like the parent graph. All of the rates of change will be the same. So I can easily start at this vertex of 2, -4, go up 1, right 1, and then up 1, 2, 3, right 1, 1, 2, 3, 4, 5, right 1, 7, 1, 2, 3, 4, 5, 6, 7. It's off the graph, but I can get it there. And it is symmetric about the vertex, so I can easily go do the other side. And connect it with a smooth curve. And this is function f of x. My parabola is not the best. Again, this technology that I'm using at home, not as good as at school. Trying the best I can. The vertex happens to be a minimum. You can see on the graph that it is the lowest point, and also since it's opening upward, of course it has to be a minimum. The parabola opens upward. The axis of symmetry goes right through that vertex. It's where x equals 2. Please remember the axis of symmetry is an equation of a vertical line. It has to say x equals 2. You can't just write 2. The zeros are the x values where the parabola crosses the x-axis. It crosses at 0 and it crosses at 4. I could put that in like set notation. Please remember this 0 and 4 are the x values. Roots or zeros or solutions are always x values. Over what interval is f of x negative? Meaning where does the parabola fall below the x-axis? Where are the y values negative? That's from one root to the next, from 0 to 4. I can write it as an inequality like that. Could have written it in interval notation also if I wanted to. Over what interval is f of x increasing? That means where is it going up? If I read a graph from left to right, starting at the vertex to the right of it is where it's going upward. So starting at an x value of 2 and forever in the positive direction. So this interval, now I just wrote in interval notation instead of as an inequality. It doesn't matter which way you write it. Please remember there are many ways that you can answer these questions. All notations that I've taught you are acceptable. They ask what is the range? Range are the y values. The range of this function are all y's greater than or equal to -4. Remember, range are y values. So starting right here and going forever upward, that's the range. If they asked me for the domain, it would be how far left and right does it go? The domain are all real numbers are from -infinity to +infinity, right? I could have written the range in interval notation. I could have said from, bracket, I could have said from -4 to infinity. So, few ways of writing the range. Domain is all real numbers. And here they're asking if we do some calculations to transform the function from vertex form to standard form, we could actually see the y-intercept. So f of x, they gave it to us as x minus 2 squared minus 4. So if I simplify this, if I do x minus 2 times x minus 2 and then minus 4 afterward, So I'd do like the distributive property or the box method to get x squared minus 2x minus 2x plus 4, and then don't forget this minus 4 at the end. And then when I combine like terms, I'm going to write my answer over here. I get f of x equals x squared minus 4x plus 0. I don't have to put the plus 0. I'm going to for a moment, because remember it says that we see the y-intercept. This last term that we write, remember when a function's in standard form, it's in the form of ax squared plus bx plus c. So the c term is actually the y-intercept. Do you see that the parabola that we graphed does cross the y-axis at 0? So standard form tells us we can see where it crosses the y-axis, where vertex form we can see what the vertex is. You can always use that graphing calculator of yours, though, if you're having a hard time graphing it the way that I just did. Let's see, where's my graphing calculator? So if I enter into the y equals, exactly as written, in parentheses, x minus 2 squared minus 4, and then go look at the table of values and scroll through to find the symmetry, I can see that these points are the points that we plotted. Do you see the negative 1, 5, and the 0, 0, 1, negative 3, 2, negative 4, and so on. So you could always write down this table of values and then plot the points. You don't have to use the shifts and know what the rate of change of a parabola is. You have access to a graphing calculator at all times. So I would like you to even, be careful. So even write down like the table that you see on your calculator. So the x values go from negative 1 to 5. And the y values are 5, 0, negative 3, negative 4. 5, 0, negative 3, negative 4. And then we saw the symmetry. And you plot those. Not a big deal. Okay? But you do have to be able to talk about shifts of functions for your Regents exam. But if they ask you to graph it, if you want to use your calculator, please do so. If we were to talk about example 2, I could see that it opens downward, it's more narrow, it shifts 1 unit to the left, and it shifts down up 8. Let's write that down. Opens down, more narrow than the parent graph, right? They're telling us to compare to the parent graph. Shifts 1 unit left, and 8 units up, which means the vertex is at negative 1, 8. I'm going to plot that. I know without graphing it that it's going to be a maximum because the parabola opens down. But let's do B without our calculator, with using the information that we know. So we have the vertex, but the rate of change is not going to be that standard rate of change. Remember, the parent rate of change was 1 over 1, 3 over 1, 5 over 1, 7 over 1, 9 over 1, and so on. Now that the number in front is a 2, I know it's a negative 2, but the negative just makes it open down. It's the 2 that makes it more narrow. I have to multiply all of these rates of change by 2. So if the number in front, remember we call that like the A value, when A is 2, now it has different rates of change. It's 2 over 1, and then it's 6 over 1, and then it's 10 over 1, 14 over 1, and 18 over 1. So I just multiplied all the standard rates of change by 2. Now let's go to that vertex that we plotted. And let's go down 2 over 1. And I'm going down because of that negative. And then down 6 over 1. And then down 10 over 1. And then let's do the symmetry. Wow, this pen is killing me. It's actually the program, not the pen. Alright, and then I connect it with a smooth curve. And label it. The axis of symmetry goes through where x is negative 1. The zeros are at negative 3 and 1. It is positive, meaning the graph is above the x-axis between those zeros. So from negative 3 to 1, and it's decreasing, or it's going downward on the right side of that turning point. So from x is negative 1 to infinity. And again, we can do some calculations to change it into standard form if we wanted to. And then we would see that the y-intercept is at 6, right? That's where it's crossing right now. So I guess let's do it. We have f of x equals negative 2 times x plus 1 times x plus 1 plus 8. If we do the distributive property to here, I like multiplying my binomial times binomial before I worry about that negative 2. That's just my preference. When there's 3 things to multiply, you can only multiply 2 at a time. So I'm going to multiply this. I know it turns out to be x squared plus 1x, which is plus 2x when I combine, plus 1, because 1 times 1 is 1. And then there's this plus 8 outside. And then I distribute my negative through, my negative 2, I should say, and I get a negative 2x squared minus 4x minus 2 plus 8, and then I combine like terms, negative 2x squared minus 4x plus 6, and ta-da! The y-intercept is at 6. So again, you can use that graphing calculator. You don't have to do these rates of change. I wanted to show it to you, but if the calculator is better for you, then use it. You do have to understand about shifts, though, remember. You do have to understand that it is more narrow. And you do have to understand that it opens downward. So, if we enter in negative 2 parentheses x plus 1 close parentheses squared plus 8, and go look at the table and go find the symmetry, I could see that these points are what I plotted. So always use your calculator if you need to, but understand shifts, understand when it opens up or down, and understand what makes it more narrow or wider. So hopefully that was helpful. Enjoy the rest of your day, and I will talk to you again soon. Send me messages if you need to. See ya.